Hello and welcome to this video. Now, what I want to do in this video is to run through a quick example using Matlab. And here we will touch a number of things. We'll touch arrays, we'll touch vectors, then we'll go ahead and touch a couple of statistic commands, okay? Statistics commands. Maybe we'll touch Matlab help also to some extent. So what I'm going to use for this video is a live script. So first thing I'm going to do is go ahead and pop this out. Now you could always undock any of the windows, any of these windows that are open. You could easily undock them, and if you want, maximize it. Since it's a live script, we don't need the Matlab command window for this. Now the results of these will show up on the right here. So what I've just done is to enlarge that portion. So let's go ahead. We're given a question. Given that x is equal to this array over here, just looking at the array 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is sequential in order. So when we are defining this, we don't have to type this whole thing out. Find y, where y is equal to x squared minus 3x plus 5. Note that this defines, note that y is a row vector. In other words, x is a row vector, we can see. Now, y is a row vector in which each element is defined by this, okay? So the first element is the first element of x squared minus 3 times the first element of x plus 5. So let's go ahead and solve this using, based on what we have over here, okay? So we have, first of all, we have to define x. If we're going to find y, we have to define x first of all. So let's define x. Because this is a vector, it's starting from 0 and it is ending at 10. With increments of just 1, then we can define this straight in one of two ways. You could say start from 0, increment in steps of 1, and end at 10. This works for us perfectly well. Okay, so let me not put a semicolon so it displays this. If I go ahead and run this, it displays, once it is done running this, then it will display the result on the right hand side. Okay, it's taking a few moments, probably because it's the first time I'm running the script. Good. So that's what you have on this right hand side here. So I'll just expand that a bit, maybe reduce the size so you could see everything here. Okay, so that's that over there. Okay, so that is the that's x defined over there. Okay, so that worked. That's the first way we could do this. This is a little too large. Let's make it better this way. Okay, so that's one way we could do it. But since we're incrementing in steps of 1, we do not have to include that 1 in the middle. If we run this, it gives us exactly the same thing. If I go ahead and run this, it gives us exactly the same thing. Okay, now we can define our y. Y is defined as being x squared, but then remember, x is a vector. We're not squaring the entire vector, we're squaring each individual element in the vector. So we need to do element-wise operation. So that's x dot raised to power 2, not x raised to power 2, but x dot raised to power 2. That does element by element manipulation. We're subtracting 3 multiplied by x. Now, because 3 is a scalar, we don't need to use the dot here. We could use the dot, but it is redundant in this case because 3 is a scalar. If 3 had been a vector, then we would have needed the dot to tell it that we're taking element by element. But since it's a scalar, we do not need the dot over there. And then plus 5, okay? I'll just simply tell it not to display this. Okay, I'll tell it not to display this. Now, the next thing we have to do after that is to plot x against y. Let the plots be red with dotted lines. So we have to plot x against y. We want it to be red. I want it to have dotted lines. Okay, and that's that. Let's go ahead and run this. I'll just simply say run section. Since this is the first section, I don't need to run the entire code. Okay, so it's running this, and once this is done, it should place the plot on the right hand side over here, which should be a square. Well, it should be a quadratic function. Y should be a quadratic function. It's taking a few moments because the first time I'm plotting with this code, usually it takes a few moments, a longer time to plot the first time. But after you've done the plot, when you just start up Matlab, the first plot. Okay, so this is what we have as our dotted line. It is red, and it is the quadratic relationship between x and y in this particular case. So that is this first section. Let's go to the second question. Now, okay, just occurs to me that apparently I left out some things here. Okay, so I'll take this off because apparently that is, I think, the solution to this code, if I'm correct. So let me just take it off and let's go ahead and solve it together. Then just run this so it takes all of that off, and well, maybe I should have left it, but it's okay. Now define T as a column vector with 50 elements with each element being a random integer between 0 and a positive integer of your choice. Okay, so what we want to do is to find, we want to define a random integer between 0 and, we want to find a random integer between 0 and a positive integer of our choice, whatever that positive integer is. So let me pull up Matlab's help and let's ask, how can we find random integers? So let's click on this button and say we want to find random integer. Random integer. Okay, so we see something here that says rand I. And what does this do? Creates a matrix with underlying class of double with rand I integer values as its elements. Let me get a little more information about that. Help rand I. Okay, help rand I. And then I check this, it says pseudorandom integers of a uniform discrete distribution. Returns an n by n matrix. Okay, so if I use it in this configuration, it will return an n by n matrix containing pseudorandom integer values drawn from a discrete uniform distribution between 1 and I max. So take notice, between 1 and I max, what does our question tell us to do? Question says starting from 0 to a positive integer of our choice. Let's select a positive integer in this particular case. So let me say I want my positive integer, I'll call the positive integer I. Let's say I want the positive integer to be 20. Okay, just a random value 20. So I want to take between 1 and 20. Do I have to define that first? No, but then let me just define that here since it states it here, and it might help the thought flow, the thought process to go through. Now, so we know how to define something from 1 to I max, but that's not what we want. What we want to go is from 0 to I max. Okay, so but look at this one down here. It says from you see I min, you see I max, returns an array containing integer values drawn from the discrete distribution from I min to I max. That seems to be what we're interested in. Okay, that seems to be what we're interested in. Something to also take note is that when you have m and then n, it returns an m, or you could put it in this format, returns an m by n matrix. Okay, so those two pieces of information I'm going to use now. What we want is a column vector. In other words, a vector that has 1 column and 50 rows. So T is to be defined as a column vector. The command we're using here is rand I. We need to define our I min and our I max, 0 and then II. And then we need to define the dimensions of our T matrix. And I'll use 50 and 1. Why did I get 50 and 1? Because it's a column vector with 50 elements. Column vector means 1 column, 50 rows. So T is defined and we're good. T has been defined, we're done with this. I could run this to just be sure, no syntax error. It runs through, no syntax error. Good. Let's go down. In fact, let me just display a message here so that we know that we're done with this. And T has been defined. Okay, T has been defined. Go ahead and run, and it will display that. So T has been defined. Good. Now, what I'll just do is go to Matlab's. Okay, so let me clear my workspace because, again, like I said, I had the code in there before. So when I ran it, I guess it wrote things to the workspace. Now, once it's done running this, I go check my workspace. Inside my workspace, I see that we have T defined as a 50 by 1 double. Okay, so that's good. It means it has been defined and it is actually 50 by 1. It's a column vector as we're interested in. Okay. Next, we have to find the median of T and assign it to a variable called MD. So we have to assign it to a variable called MD. MD is equal to, if you want, you could come here to Matlab's help and say help median. Does that command even exist? I do this sometimes. If I'm not sure whether a command exists, but I feel it should exist, I'll type help space that command name. If it does exist, it could tell me median is the median value. For vectors, median x is the median value of the elements in the for elements in X. Good, that's what we're interested in. We're working with a vector, so this works for us. So I simply can type in median of X and that will work. Okay, so I come in here, it's got to median of, in our case, we're finding median of T. So that's good. Again, I'll display a message here, display median found. We could always check MATLAB workspace to see that it has found this. Or in fact, let me not display this. Instead, let me display the value of the median. I mean, why not? It's not an array, so it will actually work. So median in this case is 11.5. Now remember, what we had was an array of numbers, of integers. So how are we getting 11.5? Well, we're getting 11.5 because we have 50 elements. 50 elements means an even number of elements. Even number of elements, the median is always taken as the average of the two middle values. So in this particular case, I think that will be the 25th value and the 26th value. The median of those two is what is taken as the median. Next, the question tells us to find the mean of t and assign it to mn. Now, I'll just go ahead and type this. You can always find the help for this if you want. Now, mean of t. Okay, mean of t again. I'll tell you to display this. Run section. Mean of t is 9.62. Now, take note that each time we run this section, median and your mean are probably going to change. Let me run section again. Median and mean changed. Why is that? Because every time we run this section, we're getting a new random set of integers. Okay, it is running this entire section. The section starts from Q2. This entire section is what it is running. So each time we run this, you get a different set of random integers. Now, if we wanted to avoid that, we could decide to come here and do a section break. So I click that twice. Do a section break such that you no longer have the two. Have it as one section, and then instead you could just run, or you could have selected this and just say execute this particular line of code and execute that particular command. So we could have done that, but I'll just go ahead and leave it the way it was before, and just keep the entire section together. So we found the mean. Next, find the maximum value of t and assign it to mx. So we want to find the maximum value of t. Mx is equal to max of t. Okay, and I'll just go ahead and run this. Maximum value is likely going to be, well, I was going to say it's likely going to be 20. In this case, it happens to be 19 because it selected values randomly. Apparently there was no 20 in its selection. Let's run the select section again. This time the maximum value is 20. Okay, so that's fine. Let's now go on. Next question says find the index of the maximum value of the elements. Okay. Okay, I think I'm not extremely on the left. That's am I? I'm wondering why this is okay. Let me just go ahead and type it there. Maybe it was a typo. Of the elements of t and assign it to a variable called IDMX. So we want to find IDMX. And IDMX is supposed to be the index of this maximum value. How can we do that? Let me come to Matlab's help. Help. In fact, let's use the documentation this time, just so that we can use the documentation. Docmax. Max is a command that finds the maximum elements. But let's see the documentation on how to use that command. Now, you could have m is equal to max of a, which is what we did. You could also have mi is equal to max of something. What does that mean? Let's scroll down and see. Let me reduce the size of this a bit. Scroll down. So mi says max finds the indices of the maximum value of a and returns them in output vector I. So m will be the maximum value, I will be the index. So let's come back here and let's go back to our live script. So what we're interested in IDMX. In other words, to do this, maybe we actually did not even need this command in the first place. So I'm going to take it off entirely. And instead, I'm going to come here and instead, I'm going to say, define it this way. mx is equal to that. Or mx, IDMX is equal to max of t. I'll go ahead and run this. And now it gives us mx and it gives us the index of that maximum term. So the maximum term was in location 30. And your mx, the maximum term was 20. Okay, so that's that. Last question for this live script. Find the standard deviation of t and assign it to a variable called st. Find the standard derivation and assign it to sd. Okay, so sd is simply equal to std. Again, use Matlab's help to confirm that this is correct. And I'll go ahead and run this for the last time. And so we have this here, and that is your standard deviation. 6.1254. Okay, so let me just run one more command. Is this necessary? Now let me go ahead and run just one more command. I hope I remember how to do this. Hist. Okay, let me just check Matlab. Help hist. What I want to do is to plot a histogram of the hist. Okay, it's actually histogram, not recommended. So there's a command called histogram instead. So let me use, let's see, I click on histogram. Okay, good. So I think I'll just use histogram instead. Histogram of x, so and so, and then, okay, good, number of bins. So let me just use that. I want to plot a histogram of the array that we created, RT. I'll use 20 bins because we had 21 bins. Since we had 21 different elements, 0 to 20. So we have 21 different elements. I'll go ahead and just run this. Let me just run this section alone. And at the very bottom here, it should give us the histogram of the numbers, just so that you take a look at it and see what it looked like. So this is what it looked like. And so if you want, you can look at the standard deviation 6.4, and it kind of makes sense looking at this plot that you probably will have something that is 6.4. It's kind of, it's reasonable. Also looking at this, it's maybe you can understand why your mean will be 9.5 or mean will be 9.28, median 9.5. Just again looking at the distribution of the numbers you have over here. Okay, looking at the distribution of the numbers you have over here, maybe that makes some sense. So I just had to throw that in there. If you wanted to visualize your data, you could obviously just look at the array itself. But in this case here, we are not just looking at the array, we are counting how many times 0 appeared. So 0 appeared 3 times, 1 appeared 3 times, 2 appeared 4 times, 3 appeared 4 times, and all the way down to 20 that appeared just once. Okay, so thank you, and that's it for this video.